All right, students, this is the start of Unit 4, and we are going to start with recalling what you know about logarithms. So this is in page 1 of your packet or the PDF. So you can go ahead and open that up, and I'm going to do a few of these with you, and then you are going to go ahead and pause and try the rest. Okay, so this, we have exponential and we have a logarithm, and we're going to go ahead and transform into each of these different function types. So we have 4 to the third equals 64 in the start here, and we're going to go ahead and make sure that we write the words to be able to say this. The base is 4, the exponent is 3, and the value is 64. Now we're going to write this as a logarithm. So we're going to say log base 4 of 64 is 3. Notice that that output, after I go ahead and complete this logarithm here on the left side, that what it's equal to is that exponent. Okay. All right, so the next one is giving us the base, the exponent, and the value. So for this one, we can say the base to the exponent of 5 is equal to 32. So we can say x to the 5th is 32. Now, for this one, we'll say log base x of 32 equals 5. Log base x of 32 is 5. The last one here we're going to do together starts with the logarithm on the right, so let's write that out. Log base 6 of 1/36 is -2. So our base is 6. The exponent is -2, and the value is 1/36. So for the exponential, we're going to say 6 to the -2nd is equal to 1/36. So we'll say 6 to the -2nd is 1/36. So if you're a little rusty on these, this is something that is going to really benefit you to spend a little time with. Get comfortable going from exponential to logarithmic and back. Okay. I'm going to have you go ahead and pause, and then I'll move to the next screen so that you can check the next 3 problems. So go ahead and work on 4, 5, and 6. When you're ready, unpause and check your answers. Okay, so if you want to pause here and just check your answers, make sure that we're matching up. All right, so now let's take what we know to go ahead and evaluate. So this is saying log base 3 of 81. We want to know what is that equal to. So off to the side, we can do a little bit of thinking. This is going to say 3 to what power, and I'm just going to put a little question mark, 3 to what power is 81? And this is using that ability to go from logarithms to exponential. So 3 to what power is 81? This next one is going to be 1/2 to what power is 8? And this last one is 5 to what power is 1? So you're going to go ahead and find these different outputs. This first one is going to be 4. If I take 3 to the 4th power, I do get 81. So if I say, hey, what is log base 3 of 81? Your output is 4. 1/2 to what power is 8? This is a little bit tricky. We're going to need a negative value as an output here. This is going to be -3. Okay, just as a little reminder here, if we have 1/2 to the -3rd, that's like saying 2/1 to the 3rd, which is 8. So just a little refresher with those negative exponents. The last one, 5 to what power is 1? That's going to be 0. Anything to the 0 power is 1. Okay, let's do the same thing with these. So we would say 2 to what power is 1/16? 5 to what power is 5 cubed? And 4 to what power is 64? Okay, so for this first one, we're going to go ahead and have -4 as our answer. So 2, and again, I'm just going to review this real quick just to make sure. 2 to the -4th, we take the reciprocal and change this to be a positive exponent. 1 to the 4th is 1, 2 to the 4th is 16. So again, just in case you're rusty on those negative exponents. And then this one, if you look at this, the question mark has to be 3. Right? That's all we'd have there. So 5 to what power is the same as 5 cubed? Well, it has to be 3. And then 4 to what power is 64? So if we're looking for that, we're going to have 3. Okay. So we're going to make a connection. If you could go ahead and turn to page 24, it's one of the homework problems, actually, number 7. And we're going to try to make connections between exponential and logarithmic functions. So our goal today is not so much to do all the graphing, but we are going to explore the connection between the exponential and the logarithmic, just like we did on those evaluate problems and on that page 1. So let's go ahead and make a little table here. And we'll say x and f of x, where f of x is 3 to the x. And let's plug in some values and see if we can get a feel for what this graph is going to look like. So let's go ahead and do -2, -1, 0, 1, and 2. And we'll plug these values in. If I put in 3 to the -2nd, that's going to be a 9th. 3 to the -1st is 1/3. 3 to the 0 is 1. 3 to the 1st is 3, and 3 squared is 9. Okay, so let's go ahead and graph just this 3 to the x. I'll keep the same color and then I'll switch off. So -2 and a speck of a number here, right? 1/9, real tiny. -1, still pretty tiny. We're just at a third. 0, 1. 1, 3. Now we're starting to shoot up, and you can see 2, 9. So exponential, you think your exponential growth, it's really going to just skyrocket here, right, and go up. So hopefully we can see here what's happening with this graph, and we're remembering our exponential functions. Okay, so with this exponential function, there is this horizontal asymptote. And if we have a shift, that will change, but if we're just looking at our just plain old here, 3 to the x, nothing's going on shift-wise, we would have that horizontal asymptote. Now let's take a look at the inverse. So the next thing is saying, hey, we have an input, and how about we look at the inverse of that function? Okay, so what I can do with this is just merely switch the x and y values. And we did this before with the sine and inverse sine. You're going to switch the x and y values, and then we're going to see what happens when I do this. All right, so some little teeny tiny number, 1/9, and we're at -2. Okay, let me just make sure. Okay, so we're here at -2, somewhere like that. And then, let's see, 1/3 and -1, so we're a little bit out. 1 and 0, okay, 3 and 1, and then 9 and 2. Okay, so let's see what's happening here. So it looks like for this one, we actually have a vertical asymptote right here. Okay, and I'm hoping you can see that if we try to cross this, let me double check here. If we actually made a dashed line through y equals x. All right, so this is y equals x. If we were to fold on that dashed line, can you see that that red and that blue would be on top of each other every point of the way? Okay, they're reflected across the line y equals x. These are inverses of each other, which is what we were supposed to graph. So what we have here is we have, this is actually the logarithm, okay? And then we have for this other one, so this is log base 3 of x. And for this pink one or red one we did, this is y equals, or f of x equals 3 to the x. Okay, now let's talk about domain and range. The domain for the exponential is all real numbers. You can use anything you want. The range, however, is above 0. We can't even use 0 because that's a horizontal asymptote. Now let's take a look. We should have just the flip-flop, right? Because we're looking at an inverse. So let's look at the blue graph. Domain, I can plug in everything greater than 0. So that's just going to switch over. So 0 to infinity. And the range is all real numbers. Negative infinity to infinity. You have flashcards from a previous, I don't know if it's in this packet still. I kind of don't think so. In the previous one where you had all the different functions, logarithms were in there. So that's something you can take a peek at as well. Okay, now let's take a look at these. This is saying 2 to what power is equal to 0? 2 to what power is equal to 0? What if we tried 2 to the 0 power? That's 1. 2 to the first, that's 2. 2 to the 1/2 is square root of 2. We could say, okay, what's 2 to the negative first? That's a half. Am I ever going to get anything to equal 0? And the answer is no. So this is undefined. Now, this next one, so I'm just going to cry. That was just the thinking here. So 2 to what power equals a negative 2? Am I ever going to be able to raise this 2 to a power and get a negative output? No. Undefined. So using this knowledge, we know that whatever we're taking the log of cannot be 0 or negative. And when we look back at our graph, look at my inputs. Everything is greater than 0. We're not plugging in any negative or any 0. So that's what we're going to have to think about with our domain. So if we look at this graph, we're going to do just 3 of these and then you're all done. So we're going to look at this. Instead of graphing this, we're going to look at what are we taking the log of. We know that this, whatever this is here, cannot be 0. So let's make a little note here. X minus 3 must be greater than 0. It cannot equal 0. It cannot be negative. So if I solve this, x cannot equal 3. And now I want you to do a little thinking table here. So we're going to say, okay, we can't use 3. We know that's going to be undefined. So we want to know, do I use the values from 3 to infinity or from negative infinity to 3? Where is my domain? If I plug in a number on this side, so if I plug in, let's say, 2. Well, 2 take away 3 is negative 1. That's a problem. Can't do it. Not that side. Okay? If I plug in, let's say I plug in 4. 4 minus 3 is 1. Yeah, that works fine. So we're able to use this side. So the domain is from 3 to infinity. So notice what this does to a graph is our shift. So we had the original asymptote here, right? And now what happened? We moved over here to 3. It shifted it to the right 3. And now we can use all this stuff here, 3 to infinity. But we're not going to graph right now. We're just going to look at this and see what is the appropriate domain. Okay, log base 1/3 of 6 minus x. We don't really care about anything else. We just want to know, what are we taking the log of? And whatever we're taking the log of cannot be 0. And in fact, 6 minus x must be greater than 0. We cannot use a negative for that or 0 for that, for the 6 minus x. So I'm going to add x to both sides. So 6 cannot equal x. Okay, so now let's do our little setup here. So it can't be 6. Okay, fine. So is it going to be from 6 to infinity or negative infinity to 6? Which half is going to be the one that works? Well, if I go over here and I plug in, let's say I plug in 5. 6 minus 5 is 1. That works just fine. I can take the log base 1/3 of 1. If I try, let's say I try 7. So it'd be 6 minus 7 is -1. Nope, can't use it. So the domain is -infinity to 6. Any number that you plug in within this domain, you will be able to take the log of. Doesn't mean all the numbers are going to come out pretty. It just means you are able to get an output. Okay, last one. 2x minus 3 we know has to be greater than 0. That doesn't mean x has to be greater than 0. This whole blob has to be greater than 0. Okay, so let's say we know this can't be equal to 0 when we solve. Oops, that should be 3. Okay, so 3/2 is our kind of split here, right? So we'll say, okay, we have 1/2 to infinity, or -1/2, oops, sorry, -infinity to 1/2. Okay, so that's our split. So if we're looking at this, let's say we put in 0. So 2 times 0, take away 3, that's -3. Nope, can't take the log of a negative number. Let's double check on the right side to make sure this works. Let's try 2. So 2 times 2 minus 3, that's 1. That works. So my domain is 3/2, infinity. Okay, when we meet for class, what we're going to do is we're actually going to work on some more of these where this inside here is going to get a little bit messier. So we're going to have to remember how to solve quadratics, but same basic principle. We know that this, whatever I'm taking the log of, always must be greater than 0. Okay, I'll see you guys in class.